What's up, everybody? Welcome back. Today we are working on our code visualizer. We are on our first post-Christmas stream. We've been trying to work on this thing for a few days now. I think this is the longest we've gone without a YouTube video, but here we are. We are finally here. It's finally time. Here is our code visualizer. What you are seeing is we have taken our image editor repo, we have scanned the entire GUI framework that we've been working on, and we have tried to represent that in some form of graph. What we are looking at is the stuff that's blue and green on the left side here is the color picker. All of these blue nodes are functions within the color picker. Maybe we can even show you what the color picker looks like. Let's look at this. Okay, can I background this and then go back to the code map and run that again? Okay, okay. So this stuff here, all of this is related to, if I go into this guy, this color picker, right? All of this stuff is code that's over here. I think yellow, if I remember correctly, is input state. So like when I click on a button, that goes somewhere. And that is like communicated to widgets through somewhere. I think that's what this like yellow and pink section is. And then if I remember correctly, the blue section is widget. So every single thing in this screen, all like the scroll bar, the button here, this like selectable list, the label, all of these things are widgets. And so like widgets should be kind of in the center, which they are. But what we're hoping to see when we look at this graph is some form of like meaningful split of where pieces of the code base interact with each other. And we are not seeing that. We're seeing like a hard line over here. I don't know what the fuck that hard line is, why it's there, but I don't like it, right? What we're seeing is garbage. The intent here is that we placed a bunch of nodes randomly on the screen. We understand how they're connected to each other. So we understand that like all of these files are in the GUI directory. And some of these, like these blue dots over here, are all in the file color, like colorpicker.zig. And we understand that these things are referenced by other functions in the code base, right? So we understand that like colorpicker references widget because he has to talk to that. What we don't understand is why our graph looks like crap. What's supposed to happen is we say, hey, I am related to these things. And if I'm related to these things, I'm going to try to like pull myself closer to them. And so that's why you see when we like open this thing for the first time, that you see like this jiggle happening, right? Because they're going like, oh, who do I like? Let me pull them close to me, right? And then if he sees people nearby that he doesn't like, he goes like, ew, I don't like you, get the fuck out of here, right? And that's clearly not working well. And so I think we want to diagnose why. We need to understand. So to do that, we need like better inspection, probably, of what's happening. I have a few ideas on like how to improve the rendering. But in reality, I think the most important thing that we want to do today is try to gain insight into what we're looking at. Right now, we've kind of just hard coded the code to like look for input state and widget and color picker and like render those in different colors. I would like to be able to like move my mouse, hover over stuff. I would like to be able to see like what's connected to what to make sure that we're like not making mistakes on like our database. I want to be able to maybe see like parent-child relationships in some way. Maybe I want to be able to like look for any like object, like any like folder in the hierarchy, any like file in the hierarchy, and see like where are all of the nodes in that file represented, like sitting in here. So probably whatever I wrote a few days ago for what we're gonna do today is like kind of like, we'll just say like I thought of this several days ago. The world changes. And let's think about like what is the actual plan of action today? The first obvious thing to me is that we need to render connections, right? So if things are pulling and pushing each other and they're not pulling and pushing each other correctly, let's at least see who's trying to pull and push each other. Probably we're gonna want to be able to like tune push and pull strengths in some way. I think we also are probably going to want to look at like damping. Things are going to like, this thing happens to be kind of stable. I suspect that later we're not going to be able to be too stable. So maybe we'll kind of like look at that as we need to. I also want to see like hover over node and see what it is. And then maybe also like show all children nodes on hover as well. Let's just start there. And once we have all this information, we can probably make it not suck. Make it not suck. But before we get there, we have to understand why it sucks, and so that's going to be like the primary thing today. So let's just jump in. I don't know. We'll see how it goes. We'll see what happens. So we want to render connections. How do we do that? I guess we draw some boxes in OpenGL. What's happening right now is we are rendering these things in OpenGLN. This is a GLFW window. We go, for every node in our database, let's draw a circle. And the way we draw a circle is we put 4 points on the screen. We say, OpenGL, could you draw this plane? And then that plane goes through this fragment shader that says, like, oh, if I am within some circle, I put out white pixel. And if I'm not within the circle, I don't put out white pixel. Wow, crazy. And so if we want to draw connections, we're probably just going to do something similar where we're going to say, okay, well, in OpenGL land, we're going to draw a plane, right? And if we were to draw a connection between some things here, we basically want to say, where the fuck am I? Hello? Here we go. We want to say, like, if I want to draw a connection between, like, let's use a different color here, maybe red. No, I don't want the color picker. If we're trying to draw a node between here and here, we're going to have to draw, like, 2 points here, 2 points here, and we'll draw, like, this rectangle between them. So we have to figure out what the points on those rectangles are. And I don't know. We'll see how it goes. So first of all, I guess we have to iterate over connections in some way. We're in the wrong file. We want to go in viz. And what do we do here? We call update node buffer. Okay. And he iterates over all of the positions in our graph, okay? And he says, let me draw some circles. Now, we also want to walk over all of the connections in our graph. So I think that the positions of these guys are determined, if I remember correctly, by the index into this thing. So like the node at position 0, so like node 0 has position 0 here, right? So if we look at node 0 and he says referenced by node 5, we can find position 5 here, and we want to draw a connection between those. That seems reasonable. And I guess probably we just want to say that we're gonna, update a connection buffer. Probably. And I think that our, like, program that we feed this shit into, we have, like, this, like, program that just renders everything. Oh, this is, like, a circle shader. Sure. So we're gonna make, like, some sort of, like, line shader. Maybe we'll just call this, like, constant color shader. And he's just going to be like, literally all I'm going to do is output the color white. For every single pixel that is in my bounds, we'll just make that shit white. And so then if we draw this rectangle, he'll just look over every pixel in the rectangle and say, white pixel now, please. So in that case, we don't need UV coordinates. We do need to output our color somewhere, and we don't need an input color. Well, maybe it would be nice to have the input color, but for now, we're just going to ignore that shit. And then we're just going to be like, we are going to output this, like, 1.0, 1.0, 1.0. How much easier can it get? Which means that we need some sort of, like, OpenGL program that can run that fragment shader. So I think we can just, like, copy paste this and call this line program. And instead of using the plain fragment shader that we call it, we're going to say constant color shader. Probably the existing name is shit. This guy, he needs a better name. Plain fragment shader. This is actually going to be like a circle shader, I think is a better name for what he's doing. And maybe we rename this to circle frog. Okay. And now what? We need to say that we have, I guess this buff is going to be like point buffer is a better name for this. And we're also going to have some sort of like line buffer, right? So we're going to be like, make me some buffer that I can work with. And then we are going to say, probably we render the lines before the circles so that the lines look like they're going underneath. I think that's reasonable. So we're going to say update line buffer here. Surely there's going to be some sort of allocations going on under the hood. Probably. We're probably going to pass in the line buff. That seems reasonable. As well as probably the entire graph structure. Maybe as a constant. And that seems like good enough inputs for now. Update line buffer. Let's see what happens. And then if we have a line buffer, we're going to have to render that line buffer at some point. So probably we just call like line program render. line buff, and we're just gonna not give a fuck about uniform arguments, and we're gonna pass in a default transform. There's no shenanigans to go on here. Okay, so what is like the easiest thing to do here actually is to start by discarding the graph. We don't give a fuck about the graph right now. Also, this is going to be called graph here, and we're going to say graph. But we actually do not give a fuck about this graph. Instead, let's just see if we can draw a line at all. So let's like define some points and see if we can figure out how to render a line between them. So can we just say that we want to render a line that goes, if this is our screen, bigger. If this is our screen, let's just put like something here and render a line between them. See if we can figure that shit out. So this is, we have like -1, -1 in the bottom left in OpenGL world, 1, 1 in the top right in OpenGL world, which means that this guy is going to be at like, I don't know, -0.5, 0.5. So we'll do this. And the guy on the top is going to be at the positive versions of those things. Okay? Now, I guess we are going to want some sort of like line width parameter in here, right? And for now, we will make that line width. If the radius of the circles is 0.025, maybe a line width of 0.025 for half the width of a circle kind of seems reasonable as well for now. I'm sure that we will tune that in the future to be smaller. Maybe we grow them based off how much we care about the connection or how many connections there are between those two nodes. But for now, we'll just say that is our distance. So I guess let's think about this. We are trying to draw essentially, if we're going to exaggerate this rectangle to look like this, right? We need to know the perpendicular line between these two elements, which I believe is just a simple like cross product here, which should give us like the direction, right? No, that's a lie. No, the perpendicular is just, the cross product gives us a thing pointing out of the screen at our face. That's perpendicular in 3D. We want perpendicular in 2D, which means that we just swap the axes, right? So we say like perp is equal to b minus a, and then we just swap x and y. I'm pretty sure that gives us a 90-degree rotation. We might need to negate one. let's see. So if this is our axis, we have an arrow that's like kind of shallow like this. We want it to become shallow like this. His y value is the old x value, and the new x value is the negative y value. Yes. Okay. So we say the AB is b minus a, and we say that const perp is going to be the vec2 of b of AB. What do we say? We said x is negative. So we kind of do this, I guess. Seems reasonable to me. Seems reasonable to me. We probably also want to normalize this thing. Probably. So I think that exists in our math library. Hell yeah. Dude, it's kind of nice. I'm used to rewriting these for every project. It is a little bit nice. I must say, I'm not the biggest fan of dependencies. We had dependency hell today in happy hour. We were kind of working on it. But the benefit of not having to write this again is kind of nice. Not that normalize is hard to write, but it's just like, it's kind of nice. It's kind of nice just having the function. Okay, so the perpendicular line. So now we have this. We have the direction that that's going to go. And we have the line width of how far we want to go in that direction, right? So we're going to say that, like, we're going to have, if we're going from A to B, let's say that we have A1, A2, B1, B2 are our 4 points in the rectangle. We'll call like A1, we'll say that we're at A plus the perpendicular direction times the line width, which I think we need to like, can we do a little const vec2 is equal to math vec2, so I don't have to like write it out again. Let's keep these guys a little smaller like this. Okay, so as vec2, we splat that shit and multiply it, and then that should be good. And then a2 is just going to be the subtraction, and b1, b2 are going to be bb minus plus minus those things. Seems kind of reasonable, to be honest. Seems kind of reasonable. So now let's just like set the points in our buffer. So we need like some points. So we need our 4 points. Oh, but these are drawn as triangles actually. So we need to be a little bit careful here. Since these are drawn as triangles, we need to think about the 2 triangles that we want out of this. We want boom. So this is going to be A1, A2, B1, B2. Jeez, you guys can read that. Those are letters and numbers. So we want A1, I think we want clockwise order for triangles. So it's A1, B1, A2. And I think that this wants, what does he want? A buffer point has UVX and clipX. Okay. So our clip coordinates don't matter because we're not using the UV coordinates don't matter because we're not using the UV coordinates in our fragment shader. So we'll just kind of slap those out. Really, our program we should just use a program that doesn't take inputs that we don't care about. But shut the fuck up. I'm not going to do that because I have code that uses them already. So we're going to be lazy, okay? And you can't stop me. And then our clip is just going to be... Don't frown. Don't frown just because I told you to shut the fuck up. I forget sometimes. Like a few years ago, I was hanging out with some of my friends, and we were like, I don't know, arguing about something stupid, and we were just yelling at each other, like, shut the fuck up for a second, my turn to talk. And somebody like who hadn't hung out with us much was just like, is that how you guys fucking talk to each other? Like, what is wrong with you? And we're just like, yeah, of course. What do you mean? Like, I forget that like other people think that if I tell you to shut the fuck up for a second, that's maybe a little rude. Maybe some people think that's rude for some fucking reason. I don't know. Okay, so now we want B1 here. And then we want A2. No, I'm just kidding. Chilling. Yeah, it's funny. Yeah, it's fine. I know. I figured you're probably fine. So this is triangle 1. This is triangle 2. And the triangle 2 is A2, B1, B2. So A2, B1, B2. And so if this all worked correctly, I guess we actually technically don't need the allocator here. We are going to need that later. If we did this right, we should see a line that goes from the bottom left to the top right. Kind of like quarter way in. Oh, you love to see it compile? Oh, fucking, we did it right. But the line width, we need to divide it by 2. We do need to do that. Half line width is line width over 2. I love it when it just like fucking works. It's kind of surprising. Yeah, that's great. And then we're seeing like the other thing drawn on top, and then we can adjust the line width if we want. If we want it to be a little smaller, we could like half it to 12, 5. I guess that's half. Not bad. Not bad. Okay, so now we can draw an arbitrary line. Now it looks like a probability graph. Yeah, it does, because for some reason there are fucking axes on the bottom. I don't know what's causing this. It's fucking weird, but that's pretty funny. You're right. Okay, so we can draw a line. Now we just need to draw many lines, right? So I guess, where the fuck did that function go? It's here. I don't know. This is line 100. This is 400. Okay, so we're like towards the top of the file. Okay. So I guess probably what we're going to do is we're going to iterate over, I guess we should probably factor this function out into a like append line points to buff. And this is going to take in probably an array list of like these buffer point things. So I think that this is in Sfrender, plain render program, buffer point, which is a totally reasonable type to have. we're going to be appending these like this. And we are going to say that we have A as a vec2 and B as a vec2. These are the 2 points that we're trying to draw a line between. This can fail because allocations can fail in this language, and we just take kind of all of this shit, we slap it here, and I guess we want line width as well. So now here we can say, make me this like array list. We'll call this CPU buff, I guess we call it. Java level argument length. Shut up. Dude, that is so true though. Just like 4 nested, like 3-word, like yeah, it's kind of nasty. I'm not the biggest fan, but we are, you know, I could fix it. It is my code. But I won't. I will eventually, maybe someday I'll get fed up enough that I will. But not today. Not today. Okay, so we have this like buffer on the CPU. Let's say that we want to append line points to buffer to the CPU buffer, and we have A, B, and line width. And then we, instead of doing this stuff, we say update buffer with, oopsies. We update buffer with our CPU buffer. CPU buff items. Okay, so if we did this right, nothing should have changed. Fuck! We have to write try. True. True, true, true. And then he's pissed off because... What the fuck? Oh, yeah. Instead of doing this, we're supposed to append. So let's do this. Append to the slice. We need to write try here because it can fail because of allocations. And then nothing should change. Line. Hell yeah, we still see our fucking diagonal lines. And now that means... What is look? I should be maybe a little bit concerned about this like leak spam. If we we're gonna be in trouble. Oh, but that's okay. I think that's just because like when we were testing this like widget stuff, I think I just forgot to write like this. I think that's all. What is he pissed about now? Oh, I forgot to write defer. I hate it when I deinit stuff now instead of later. Little mistakeys. And then no more leak spam? Hell yeah. Okay. That I didn't actually have to worry that much about that, but it's nice to have the logs, you know, reasonable. And okay, so now we should be able to just start like figuring out where the fuck our connections are. So I think we just like rip the graph and we just say like for graph nodes, graph positions, graph 0, graph nodes, len is probably easier. Probably. We have node is graph nodes I, and we say for refs. We are referenced by this ref ID probably. And now we can just go like, I guess we have A here is our node, right? So we have graph node positions at I, okay. And then B is the graph positions at ref ID, and then this is like a strong type node ID. We're kind of violating the constraints of that by using that directly as an index into an array, but you know, we'll fix that in the future. I don't really give a fuck right now. Okay, so we should just be able to be like append points to buffer with A and B, question mark? That would be fucking sick if that worked. Would be kind of fucking sick. That's a maybe. It's kind of hard to fucking tell. It's kind of hard to tell, but that's like a maybe. Let's reduce the alpha of these things. Maybe we say that these things have an alpha of like 0.1. And then as they stack on top of each other, I'm hoping that they like kind of add. That's pretty fucking sick. That's actually so fucking sick, man. Look at that. It's like a fucking spider web. It makes me wanna freak the fuck out. But that's pretty sick. Color also, I suspect we probably want these to be kind of more like gray so that they don't like override the nodes themselves. So can we go like this or something. Let's just kind of see what that looks like. I guess actually probably what I want is 1.0 with a lower alpha. It's kind of like equivalent, but yeah, that's pretty good. That's pretty good. A more minimal example might help see what's going on. I agree. But really all I was trying to understand here was if these things are like supposed to be connected to the middle. And it looks like they pretty clearly are, right? So that's pretty sick. Would be kind of fun to poke them around, like click and drag. I bet you that's possible. Because like technically the simulation is just like still running. Okay. I actually think working on the push and pull strengths. How the fuck do you spell this word? Strengths. Is not what I want to do. I want to be able to well, we know for sure, I guess, that this stuff is being pushed way too fucking aggressively. So maybe we do want to start tuning strengths a little bit. Let's just kind of see if we tweak some numbers, what happens. So if I remember correctly, we have kind of a crapshoot of code here, but I think that we run in 3 stages. We have this, which is, let's just be clear, for anybody watching this and being like, wow, he writes shit code. I do write shit code, but I am planning on cleaning it up later, okay? These would, it would be nice if your step function was like, calc pushes, calc pulls, like dampen, apply movement, or whatever, right? That'd be nice, but we just didn't do that yet, and we're not there yet, okay? So we'll get there, Don't freak the fuck out. I have 25-year-old code I'm planning on cleaning up later. Well, my rule is that I can't commit it until it's cleaned up, so we're just gonna have a never committed project. Later for me means never. What does it mean for you? The rule for me is that I can't commit code until I'm happy with it, which means that like it's hard to get too far because I want to commit my code so that it's clean, so that I'm not like freaking out. Like you can only sustain this for a little bit, you know. So probably once we get like our first prototype, like the first render that doesn't like suck ass, that will probably start getting cleaned up into something. Okay, so this is pull referenced nodes. This is pull towards our parent. Okay. This is push adjacent, push nearby nodes away from us. And this is like apply movement. Okay. Okay, so the biggest question I have is like, what is causing all of these guys to be like stuck in specifically this location? Right? There's something weird about where they're stuck because they're not stuck at like the edge. They're stuck at like some percentage in from the edge, and that's fucking weird. So maybe actually the first thing we do here is add an overlay. I want to add some sort of like overlay of node position. I want to see what happens. So I want to like let's start by like figuring out which node is closest to the mouse. I think is reasonable. We color that node differently and put a little bit of metadata about it somewhere. I think that will help us understand the world a little bit better. So maybe we say like detect node under cursor. Maybe a slider for the push pull force. I think that that's also likely to be done, but I think we need to determine how we want that to be represented. But yes, we will get there. That's why we kind of prep the GUI framework for import in Happy Hour today. Okay. So how do we detect the node under the cursor? I guess we just rip the graph and check each node position for which one is closest to the mouse. But that means we need the mouse position, which we are not getting right now from GLFW. So we need to do that. So we need to say like glfw mouse. I think there's like some sort of like callback. Is it this set mouse position callback, or is it get mouse position callback? Can we go here and say glfw mouse? Actually, while we're doing that, we can just look at what we did in our other code base. Main source main. Cursor position callback. We set with set cursor pause callback. Yeah, okay. And what did we do in that? We can just copy paste that as well. So here we say we have some glfw thing. We have some queue of actions. We're not gonna do this as a queue. We're just gonna say like mouse pause is going to be a vec2 here, and we'll just say like glfw mouse pause is equal to x pause floatcast. Okay. Okay. And then do we set the user data callback here? User pointer self? Yeah, we do. Sick. So we should just be able to like on every frame print out the mouse position. Mouse pause is this. If we did that right. Fuck. Mouse pause equal to 0, 0. Okay, so he goes down here to like 800, 800, 0, 0. Looks like we're chilling. Okay, so that guy is totally chilling. And so now we just want to convert those into clip space. So I guess where's our like 800 by 800 window? Const window width is 800. Const window height is 800. Okay, and then we should be able to be like, I don't know, find item under cursor. Okay. This is going to give us a node ID, probably. Seems kind of reasonable. Maybe a usize for now is simpler. Node ID is kind of like more correct. And well, I don't know, usize. We're going to take in the graph as well as the mouse pause, which is a vec2. And this is in pixel space. So the first thing we're gonna do is convert this thing into clip space, because that's where everything else is defined. And what do we do here? I guess we need like the window width. As a usize question mark, U31 question mark, like F32 question mark. I guess F32 is fine because I think it's a comp time int and those autocast to floats. Okay, and that will make the math easier. So let's do it that way. And so the mouse pause clip is just like mouse pause pix over window width and height, and then this gets us 0 to 1, but we want -1 to 1, so we say times 2 minus 1. Chillin'. Okay, so we have our mouse position in clip space, and so we just need to find which thing it's closest to. So for 0 graph, for each index in the graph positions, we look for which one is closest. So we say closest dist is going to be infinity, and the closest index is going to equal 0. Okay, and then we say if we are closer than the closest distance, so we need to find the distance, mouse item dist is going to be mouse pause clip minus graph positions at I And is that already vec2? It is, so we're just chilling. We say if mouse item dist is less than closest dist. Do you need minus for py? Yeah, you're right. You're right, thank you. You are right. Not that, yeah, that would have caused problems. That would have caused problems. Thank you. If we are closer, closest index is I, closest dist is equal to dist. And then at the end, we have it. So we just say return closest index. No. Yes. Yeah, okay, sure. So then at the very end, can we just go like find item under cursor given the graph and the mouse GFW mouse pause and the window width and the window height. Item under cursor. And then can we just be like, let's render some fucking circle here. So can we be like a graph positions at item under cursor? Render that thing in like, I don't know. Let's make them fucking hard green. That seems reasonable. See what that does. Fuck. This thing needs a 0 on him because he's the first. The X position. This thing needs a Y. There's still a typo for PY. Window height minus this over window height times 2 minus 1. I don't see it. That seems fine to me. But maybe we'll find out. I'll find out later what you're talking about because you're probably right. Mouse item dist. We do this to be length. We'll use length squared because we don't. It's cheaper to calculate and doesn't matter here. Okay, so that's not doing anything. Can we look at like? Okay, so find item under cursor. Sorry, 0 and 1 didn't know that. Oh, that's fair. That's fair. Yeah. Oh, I see. You're saying like I used width for both. Would have been what you were thinking, which is a reasonable thing to think. Where is this debug log coming from? Mouse pause. Fuck this shit. And instead, can we say std debug print item under cursor is this thing? Let's just see. Oh, he assumed px and py, but what I meant was a pixel, not point x. So I don't really like that. Like when I'm here, 8 is the correct answer all the way up here, which is clearly wrong. It looks like it's kind of like correctly moving along in y, but not really in the way that I would like. I also don't really see a green thing being rendered. Let's just make sure that we got that right as well. So we update the point buffer to say only draw this one point, which seems reasonable. And can we draw it in like, maybe we should log the position of the thing we're rendering to. I also kind of feel like the whole world is like maybe shifted for some fucking reason. It kind of feels like that a little bit. So maybe it could be that like, is my viewport set? It's not. I bet you that we should probably set our GL viewport. I bet you that's gonna cause some problems. No, that's surprisingly the same shit. Can we render their positions? Can we just say like, is this at this? Graph positions item under cursor 0 graph positions item under cursor 1. Okay. Does this tell me anything interesting? So my Y position is always 1.2, which, first of all, nothing should ever be at 1.2. Things should be clamped to the -1 to 1 range, but that does explain a little bit why everything is on a line here. I wonder if everything is getting like pulled up into the right every frame, and we're not clamping it correctly. Let's look at like our clamp code. Let's look at our clamp code. We clamp here, and then we move stuff to so that the center of the screen matches. So it's almost like we want this clamp to happen at like the very fucking end. There we go. That's like more reasonable. This is still like fucking stupid. But at the very least, now we can see every node, and you can see that like there's this cyan bubble kind of moving around at the top of the screen. I think that my Y position is not behaving reasonably, but at least we can see something. I'm pointing at my screen with my finger like a fucking dumbass. At the top here, you can see like a little cyan thing kind of like shifting around. So why is it always seeing, why is it always picking something at 1.0? Find item under cursor. Let's log mouse pause clip. Mouse pause clip is this. Mouse pause clip. All right. The fuck does that do? Yeah, my mouse pause clip is like 700. So it's actually, this isn't supposed to be window height, this is supposed to be 1.0. Okay, so now down here, we're seeing a mouse pause clip of like -2, which is wrong. And at the top is 0, so 2 minus. So now this is -1 at the bottom. And this is 1 at the top. I think this is right now. So if I hover over this, it's like kind of, yeah, it's definitely detecting what I want it to be detecting now. Which is pretty cool. Pretty cool. Okay. So now hopefully we can try to like gain some information about those things. 2 minus 1 equals +1. I'm pretty sure it's right. 2 minus negative, because here I have, oh, it's because I've got like -1 here. So it was supposed to be -1. It's like this. Yeah, 1.0 minus this thing. This thing is in the range 0 to 2, this section, which means 1 minus 2 is -1, and 1 minus 0 is 1. Yeah, that makes sense. Makes sense. Makes sense. Quick maths. Yeah, I mean, you're kind of assuming that we're like doing math. What we really do is like, I like to call it vibe-based math. You just kind of like throw numbers around until they work. You go like, it's too high, so we make it lower. You know? Who cares about getting it right? And then if that doesn't work, then we think. But typically we go vibe-based math first. Okay, so what do we want to do with this information? We want to say probably, okay, we have detect node under cursor done. And then I guess we've kind of figured out the node positions. It would be nice to show those on the screen. And I would like to say like, show its position and maybe like who he is. But I guess maybe we have like logging of node position. That's good enough for now. We don't have to get crazy. we don't have to get crazy. So this explains, we've kind of figured out why there was that shit show of like things in the bottom left corner. It was because the average position was pulling it to the side. Now we have to figure out, it seems likely that we are just pushing too hard. That's kind of what it seems like to me. Now, if we look at what we're doing for pull and push, we just kind of made this up. I think that we ended up doing something that's very similar to something that is called force-based diagrams. I was Googling like how people do layout, and the word force-based diagrams, they were talking about like springs and stuff came up. We're not tracking movement at all, so we're not really like working in like acceleration space like a spring-based thing would. But we did just kind of say, we want some function that starts at 0 and caps out at 1. And we want some function to calculate like the push. So if things are like really, really fucking far away, we want that to be like 1.0. Bring me the full distance back to my object. And if they're like really close, then like we don't really give a fuck. So I think what we ended up doing was we said some max distance times distance over 1 plus distance. So if we just like Desmos that shit up, we did x over 1 plus x. I guess we should call this distance here. And then we multiplied this by max. So we need this. Where's my fucking hello? Hello? Oh, D, we don't want a slider. D is hello, x over 1 plus x. Oh, okay, x needs to be a fucking thing. And then we multiplied this by max, right? So this is kind of like our pull force. Hello. And so depending on what we like to say is our like max step, this graph is going to look like more like this or like this, right? But kind of overall, there's like some value that it approaches, and we try to like nudge graphs or nudge elements that are like pulling each other by that amount. Push is we did this. Why the fuck did we do this? I don't know, man. Let's look at it. So can we do like 1 over 1 plus x? Why did we do this? Why didn't we just do 1 over x? Ah, I see. So we wanted something that is 1.0 at 0 and then gets smaller. Kind of like, you know, backwards of this, right? And I guess this is just hard divided by 100. Right? Now, this is applied for every single node in the graph, I think. So I think that as we add more and more nodes, just the push strengths just inherently get stronger. So I think that we probably just want to change this 1 over 100 to like an M2, right? And why is this not being shown anymore? Ah, here we go. Because we're just zoom the fuck in. And probably we just want to reduce this slider by number of elements. Probably, right? So that like we kind of want like, you know, in like video games, when you like drive your car in between two rocks and it gets like wedged in there and then just goes like fucking flying into the fucking nether. I think that what's happening there is like the physics in your video game runs at like some interval, right? And as like if the amount of movement between steps that the physics engine takes is like too much movement, things just go like fucking flying, right? So I suspect that what we want to do is we want to like ensure that the maximum movement that will happen, the maximum reasonable movement that will happen is like small. You know what I mean? Shouldn't it be M2 over M2 plus X? What's that do? So that the maximum push is always 1? No, I think, although I think that's also interesting. I think there's also something interesting about doing like times C. Right, you can kind of like adjust this as well. But I think for now, I'm okay with 1 over 1 plus x times m2. Because probably actually, Yeah, because this is like the maximum distance that we are willing to move in one step. And what we're going to do is we're going to make sure that M2 is essentially like some maximum distance divided by the number of nodes that could be pushing us. That way, once you add up every single node in the whole graph, if every single node was like right next to you on the left, we should still only move by some maximum distance to the right. You know what I mean? I think that that'll work out that way. So we have this like max distance thing on calc pull. I think we should just apply that same max distance. Or we'll call this like, oh yeah, max distance here. And we do multiply by max distance here. And so that makes us M2. And then we just try to make this shit like kind of small. So here we probably just want to be like, max distance is going to be, I think we're going to define like some sort of like max frame, max desired frame, max frame movement. Okay. And we'll call this like something like kind of small, right? Maybe 0.01 even. Something like really small. That's like 1/200th of the screen, I believe. Yeah. We can start small, we can always bump it up, and we can maybe like attach that to a slider and stuff later. And so I think we want to say that on push, we want to do max frame movement times or divided by the number of elements in our entire graph. I think. So let's just kind of see what that happens. I assume that what's going to happen here is everything's going to be like way too close to the middle now. Yep, that makes sense because now our push force is like way too small. I don't know, what the fuck is this thing? Can we like see what these, this looks like, this is mesmerizing. Woo! I can't stop looking at it. Okay, so I want to know what's going on here. Why are these guys getting pushed so far away? Why are they never getting like yoinked towards the center? I guess because no matter what, if their pulse, I mean, some of these guys don't even look connected. This guy, some of them definitely are. But they must be connected like really subtly. Can we maybe check here that can we like log like movement for this thing and make sure that it's less than the max frame movement to make sure that we did the math right? So the two are connected to each other? Could be. So let's say that we have like total push movement is 0, 0 vector. And here we say total push movement plus equals push. Okay. And then can we just like std debug assert that push is less than std math length of total push movement is less than max frame movement. I just want to make sure that is the case, which it looks like it is. And so we could even try reducing that further, but I think that that's fine for now. Now, we need to apply this kind of same logic to pull. Now, for pull, we're willing to move a lot harder per interaction, but we probably still want to like apply some limit of the maximum move distance divided by however many nodes could pull us. So it's going to be like the same thing here. Calc pull of other pause minus pause, what we said here. And then we just have max frame movement over node reference by len. All the people that are pulling me around. And then here, I saw this while I was looking at this the other day. I don't like the idea that what happens is we say B references A, right? And what we do is we're like, okay, we need to get closer to B. But that's not like how this should work. I think that what should happen is we should say A and B should get closer together. And that's what we do on push, where we say like, okay, what's half the push? Now apply those to like me and the other guy. I think we want to do the same thing here, where we calculate half pull, because otherwise like somebody wins, you know? And that's kind of lame. You kind of want like things to attract each other, not to just like, not for one guy to kind of be centered, I don't think. I think that will improve things, but I don't know. It just seems a little nicer to me. So pull over 2, we say that the movements at ref value, we need to make sure that we get this in the right direction. So we did other pause minus me. So I have to move towards that guy, which was movement dot star is increased, half pull, and then the other guy is pulled towards me by that amount. So ref value is negative half pull. I guess we could say minus equals half pull instead of plus negative if we wanted to get crazy. Distance scale is no longer used, and let's just kind of see what that looks like. Fuck! What the fuck? Mix scalar and vector operands. Should this not be a vec2? Vec2 over vec2. So this is a vec2. And movement should also be a vec2? So like, what's he bitching about? Is it because I had to do plus equals negative? Is that true? Movements, plural? Oh, that's a really good point. Thank you. I was indexing into the vector. That's something. That's definitely something. Okay, so density is too large. So I think what we want now is we want to adjust these functions so that basically the blue line and the red line intersect at a larger number. I think that's what we want. So I think we still want the maximum movement in a frame to be maximum frame distance. So I think we don't want to touch M2. What I think we want to do is we want to touch X. I think we want to do this and just like adjust like the slope of this so that it kind of meets farther up. That's kind of what I'm imagining. But I could be wrong. And then we probably want to do the same treatment here, right? So maybe we want to be able to tune both like this guy and this guy independently, because probably we want the intersection to be at like some, I don't know. This controls like sloppiness, I think, like how aggressively. Okay, so this controls like how much movement can happen, and I think this controls like how far we have to be from the other guy for that movement to take effect. I think it's like something like that. Oh shit! I wanted to do this C2 up here as well. There we go. That's what I was looking for. Right. So now we kind of say like how aggressively do we pull things that are like towards that are close to us versus far from us. I think that's kind of what we want. Yeah, something like that. So if things are like too close together, we either want to change this aggressiveness so that we kind of push things more linearly. But I suspect that we want like really aggressive pushing at the start with like a steep fall off. That's kind of what I imagine makes sense, right? We have like we want to approach 0 on pushing, as soon as it makes sense, because we don't want to affect everyone. We only want to affect. We're basically just using push to say like we don't want clumps. So I imagine that we actually want like a really aggressive push constant here. With then we want to tune this guy until they intersect at the right distance. Right? Is that correct? If this guy's 1.0, I actually then need to increase the steepness of this pull for them to intersect higher. I think that we want them to intersect lower. That might be more correct. Because push and pull are in opposite directions, so there's something weird about that going on. My intuition says that this needs to be low for them to get farther apart, but looking at the graph, I don't really understand why. Reduce M, but I think that M is like how much I want things to move within one step of the physics simulation. Right? So like I think that like at the extremes, I want like when things are like really fucking far from each other, I think I still want M to be the same value, right? I want this to approach the same number. That's kind of how I'm feeling. I could be out to lunch. Could be out to lunch. But I think that I don't want to adjust, like, if something's really fucking far away, I want it to really aggressively come back. And I want it to aggressively come back to the same amount, by the same amount. I'm much lazier with these problems when I import a lib so I can tune the numbers live. I mean, we're probably about to do that, to be honest. We prepped the GUI framework. The x coordinate of the intersection is what's important, I think. Oh, that makes sense because x coordinate is the distance. Yeah, you're right. We did prep our GUI framework for input part so that we could do that. So I think probably now is the time. Now is the time to do that. At some point we started like tuning stuff. I don't really know when that was, but that was sometime before now. Started tuning or something. Math, graphs, who knows? I don't remember. But now let's say it is time for us to import our GUI framework. GUI framework time. So let's say we'll have like constant tuning. Live constant tuning. Okay. So we have the tools for this. We have, it's hard to see here, but it does say hello world in the top corner here. We did manage to import our GUI framework in Happy Hour today. And so I think the play is we want some form of widget somewhere that has a property list of like key value pairs. So let's start by making a property list. Property list. And this property list is going to have some floating point values. So we're going to say like, let's name these things like, we have like, we'll call them C and max. Like multiplier and max maybe? Sure. So we'll say like, property list push widgets with, I don't know, we have like some sort of like key and value here. Key is going to be a widget label of like, the first thing is multiplier, like a, sorry, pull multiplier, we'll call it. And if we fail to do stuff, then we deinit this guy, of course, with an allocator. And we have some sort of value widget, which is going to be a drag float. And we need to say that, how do I retrieve the value of this float? Well, I guess that's probably part of the graph, right? Our graph is going to have like pull multiplier. Okay. And then on pull, I guess we will multiply by that pull multiplier, right? So the distance, the input distance is, I guess it's here. I guess we'll take in the multiplier like this. And then we'd say times multiplier times multiplier. And then calc pull needs to say self pull multiplier here. Okay. So we need to get that value from the graph. I think he has a very stable memory location. So I think it's totally fine for us to just be like graph pull multiplier. I think we can just use a reference to the value. And then our action is going to be when the float changes, we're going to say change pull multiplier multiplier to this new value. And we need to pass in a function that can generate this UI action. So the function takes in like a value of the new F32, and he returns the UI action that is going to be performed. Okay. Which means that we have to be able to go like return change pull multiplier is equal to val. Okay, simple. And then we pass that into our widget when we generate it, wherever the fuck that was, over here. So now this is like UI action change pull multiplier, and the drag speed will say like some number. We can tune this if we want later. Okay. So then we want to render this property list somewhere. So instead of rendering this label, can we render the property list? Okay. And what happens if we do that? Fuck. Fuck. Interesting. We are doing something different. Our parent pull, we need to fix me here. Fix me tune parent pulling. This is just like needs same changes as other pull push. But for now, we'll just kind of leave it the way it is. Update is not parked pub. I think we need to say like property list as widget probably. I think that's what he wants. Okay. Get size as well. Everything that uses this thing needs to use them as a widget. Fine. Fine. Okay, so we have this like really fucked up property list that's trying to fill the size of the window. So we probably want to like clamp it in a little bit, and then also we need to fix our mouse interaction. So I think we just say that the width is going to be like, we just say you can't fucking be more than 300. Okay, so that's pretty good. This thing is kind of lining up in the right spot, and now we have to fix our input. So, I don't know like how the fuck they did it here. They being us. We have some sort of key callback. Okay. Do we care about keys? No, we just care about cursor position and mouse buttons. We don't care about keyboard right now. So we copy the mouse button callback. And we go to source viz. So we need to do something on mouse button. We need this window action, which I think is coming from like UI window action. Nice. Log error, we just ignore that for now. I guess we'll std debug print this with the error name like this. Okay. Our GLFW abstraction needs a queue. So what do we do here? We have queue like this. That's just kind of the expectation here. I guess we'll just copy it. You know, we can do whatever the fuck we want, but we'll do it like this. FIFO comes from what? This. Okay. Yoinkies. Pasties. Okay. And then window action comes from GUI here. Okay. And then I guess here our mouse positions are also defined by the FIFO. So we might as well just kind of follow the same pattern as we did in the other guy, if we are going to be like that. So Oops, it's viz.sig. Vizzig. So how does our other example... Oopsies, fuck. How does our other example handle mouse position? Probably he, like, consumes the input queue in some way. I think there's some sort of, like, input state handling that we're supposed to do. Yeah, he does this. He says, hey, we are at the start of a frame. Let's read items from our fucking queue and slap them into this thing. Okay, sure. So we're like, which means that we need an input state. Our GUI framework's not quite there yet. We're getting somewhere. So this is input state. I think we just kind of do this. Yep. Okay. So then we say input state start frame. We say GFW queue read item, and we push the event into the thing. And then now we can say we can pass the input state into the property list. So we say update set input state with the same widget bounds. Input bounds are the same, probably. I think we want to know, like, we want to make sure that we clamp input to the size of the widget. Okay, let's do this. Property list widget is equal to property list as widget. Then we don't have to fucking type that shit over and over again because it's fucking annoying. Property list widget, we say, please recalculate your layout given the new data that you have. We say, what is your current size? Property list size is this. Then we say, could we please set your input state? So here are the bounds of your widget. I guess the widget bounds are going to be from the top left of the window. Okay. We say start you at the top left of the window. We could add a padding to this thing, but I don't want to right now because I don't give a shit. The right is just like, how big did you want to be, property list, you know? Let's ask. And then the bottom is like however tall you want to be. Great. Now when we say input state, we say, hey, this is like where your widget is. And also, this is where you're allowed to accept input, which happens to be the exact same amount, but in some cases it's not. And here is the current input state. Boom. Boom, boom, boom. And then he's going to say like, hey, could you fucking do something, please? Is what he's going to say. Is this thing failable? No. Okay, then we render him, but after we render him, then we apply actions. Height for bottom. True. True. So then we say, okay, you asked us to do something. We told you to ask us to change, what is it? It's like action here. We asked you to ask us to change whatever the fuck we wrote on that. Change poll multiplier. And so we sure will do that thing. So you're like, yo, change the poll multiplier with this value, new value, and we just say graph poll multiplier equals f. Okay, so if everything is right here, we should be able, fuck! I guess we have to make this FIFO too, huh? How do we do that? FIFO, how do we construct this shit? It's literally just FIFO.init, okay. Okay. If action A. If there's something to do, we do the thing. He's mad at 620 now because the mouse pause is not known that way. This now comes from the input state, which is fine. Expected this, found mouse pause. Yeah, that's fair. These are very similar, but they are not the same. So I guess we'll just call this mouse pause like this. And here we use X and Y instead of 0, 1 like that. Okay, we're getting close. 21, he's pissed off because here we now have to do the same shit as in the other version where we push to the FIFO instead of just setting the value manually. Mouse cursor positions, they did this shit. Okay, fine, we'll do the same shit. Error name, E. There we go. Should work. We're so close, we're so close. This needs to be in these squigglies. And maybe. Let's go! Okay, so now the thing's just not happening. But the input say we can tell that like it's working. Oh, it's because click isn't fucking working probably. Because we have to actually assign the mouse button callback. So here we have to be like, oh, oops, wrong fucking file. Yeah, we just have to assign the set mouse button callback to mouse button callback. There we go. He didn't know that we clicked. What's he pissed off about now? What's he fucking pissed about? Probably in mouse button callback, we probably fucked something up. I would assume in here. I assume that's where the bug's from. No, actually, surprisingly. I hate these like fucking print errors. I'm pretty sure. Oh, wrong one. My bad. It was in this one. I really wish the fucking backtraces for these like print errors went to the right spot, but it is what it is. There we go. Okay, so we have to be careful with how far we're willing to go here, but it does kind of look like it's working. It's kind of exciting. Kind of exciting. Kind of exciting. That's pretty sick. Okay. So now we can just start like hucking more tunables at this guy. So we want push multiplier, which is gonna be like go to push multiplier, and he's gonna say like, hey, when this thing changes, ask for the push multiplier to change, please. Which means that we need a action for change push multiplier, and which means that we need a function to generate the action to make the change push multiplier, which means we need a handler for that thing, which means that we need to write push here, and that means that we need a push multiplier. It would not be a Sparrow film if mouse pause was not logging every frame. Hey! I just... Details are not my strong suit. I see, like, it's just... My brain's so, like, effective at just, like, tuning things out that I'm not paying attention to right now. So I just, like, actually just, like, had no idea that was still happening. That's pretty funny. Okay, so... I think that the push multiplier, we want to go here. And then, what do? We just multiply dist by that thing? Okay. And I think that's all we need to do here. So calc push, we have push multiplier like this. And now we should have two things to move now. So here, if we increase the push strength, weirdly, things get smaller. Yeah, so if we increase this a lot, things get closer together, which I guess makes sense if you look at this calculator, right? Here, we're saying that we want to move the intersection farther to the right, and as we increase this thing, we are kind of saying like, hey, I'm gonna push stronger. I'm gonna like fall off quicker, essentially. I'm gonna let things get closer together before I start pushing really hard. So we almost want this to kind of be like really low, which kind of lines up. Well, it depends. Maybe we want fall off to be really hard. Maybe we just want to increase the maximum push that he's allowed to have, right? We say like, hey, you can fall off really fast, but things that are really fucking close together, like push those like out the fucking wazoo. Like just like slam those motherfuckers. Seems pretty reasonable. Okay, fine. I'll fucking remove those prints. Okay, are you fucking happy? Oh, now we have this. Mouse pause. Quip. And it doesn't even have new lines. The lack of new lines is also a fucking classic around here. Yeah, okay. So let's just say that we have like max push and max pull as things that we can tune as well. And really this is looking very factor outable. Huh? Append to property list. I don't care. I do care. I do care. I do care. I care. Widget factory is a UI widget factory of UI action. And we have the graph. We want like the element, which is a float pointer. So that's going to go here. We have the action gen. Append float to property list. So this is going to be like some function pointer that takes in a F32 and returns a UI action. Okay, so that goes here. And then the property list. So this is a SVUI property list of UI actions. Okay, chillin'. And then now these like squiggly brackets can be like append to float to property list. And we're gonna be like, here's my property list, bitch. Okay, I don't need to be so mean, but I can't help myself. And oh, we need the key as well. We need the name. Name. So this guy gets the name. And then we get like widget factory. Is this a pointer right now? It is. So this is like this, and then we have pull multiplier is these things. I think that's what this looks like. Okay, and then can we put a fucking yeah? I mean, it's actually kind of funny. This is like the same number of lines of code, but it's probably nicer. So this is push, push, push. And let's just make sure that still works. Okay. So this, we shrink it, things start to get farther apart. Here we increase, they get closer together. All right, cool. I don't like that. Oh, this is coming because I don't free the property list probably. Probably. It's probably important. What's being pushed up to the top left? Probably just like some shit that doesn't matter would be my guess. Like something that's like not actually connected to the rest of the graph, so nothing's like pulling it back in. But we will have to look at that eventually. Okay. Now what we can do is we can say like we wanted to tune the other constants, right? So it was the max push movement. I guess max frame movement. Both of those seem reasonable to kind of like stay fixed. I think what we're missing is we're missing that we have to fix the parent pull as well. The parent pull needs the same treatment. So first of all, let's do half parent pull like we did over here. Like this. We need to make sure that we are using the correct people. So what are our two elements here? We have movements at parent ID value. Oh, interesting. We pull parent with us a little bit. What is going on here? Whoa, what's going on? So we say pull the parent with all the siblings. Do I like that? I suspect that I don't like that. I suspect that I want the parent to just naturally move with the children. It's kind of what I'm assuming here. So I'm going to take this out. It doesn't really seem reasonable. We might add it back in if it doesn't look reasonable. What do you think about adding 7 TV emotes? I just don't really know what they are. You know, I just don't. I'm not really much of a. I'm not much of a emote person, or even really much of a. How do I call this? Like chatter, to be honest. So I think that what we were doing here is essentially the same as saying like parent pull multiplier here. And then we need to apply the same max movement here. So the max frame movement over probably the number of children is probably what we want to do here. I assume is the play. So we want to go over self num children at parent ID value. Dotlin? Num siblings, I guess we already have. Yeah, so we say we pull the parent by 1 frame movement over the number of siblings that we'll be pulling on this guy. And I need to look at the diff here. Before we're doing movement is plus parent pull, so we're doing the pull towards the parent. And then the parent ID value is pulled by the same amount in reverse. Okay, so now we just need the parent pull multiplier here, which doesn't exist yet. Which means that we have like parent pull multiplier, and then down here somewhere we have like change parent pull multiplier here, which means that like up here we need parent pull multiplier, and that means that we need like the function that generates the parent pull multiplier for our widget to send out to call. Which means that we need a widget that does that thing, so we'll just say that the parent pull multiplier goes here. And should do it. I don't know what the fuck I just typed into my control R, but expected F32 found vector. Let's see, what do we fucking do wrong here? Max frame movement. This is an F32. This is a float. Ah. Okay. I don't know. Expected type found F32. Right, so we don't need to do float from int here because it already is float from inted up above. Okay. Okay, so here we increase the parent pull multiplier. Before it was like 5. Okay. Okay, hold on. So this is... Oh, right, because the max distance move for parent pull has been is a lot lower now. Which means that every movement is a lot smaller. So I think that we want to tune the max movement as well. I think that's the play. Yes. Yes, 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 yes. Okay. Change max movement. Max frame movement. Okay, we need to just do the same shit again. Change max movement. Change max movement. Change max movement. Max movement is backed by the graph max movement, and we say when please change the max movement after that thing. Okay, so we say like, let's just, oh, We didn't say we didn't change the right value. Okay, so like, oh yeah, so here you can see that we can start getting into like mega frame instability. Oh, holy shit. Right, even just like crank it up like that is like too much. Okay, so now let's say that we want everyone to be more aggressively pulled towards their parents and just pulled towards things in general. But like we probably want parent connections to be worth more than regular connections. And it looks like the general push multiplier is too high. It looks like we still have instability here. You see like these brown nodes means that there's like heavy flickering, which means that the max movement is too high. Right? You can kind of see here that like if I reduce the max movement, then these like instability sections start going away. So maybe a max movement of 0.05 is reasonable. And then we just need to start like tuning these things so that they look more reasonable. I think I want like more push. Okay, so we have like the multipliers, but I guess we also want like the max. Do we want like a different max movement for pull than push? What does that look like if we were to like start tuning this? I think no. I think that we always want well, I guess like inherently yeah, I wonder. I could see a world where that makes sense. But maybe we can get the same behavior by tuning like the multipliers. I mean, we said before that those are different, right? Those like steepness. And I kind of want the like I kind of want an like a very aggressive mac like push if things are like infinitesimally close together. Right? So it's almost like max push distance. I want to be different. It just kind of feels that way. So can we do like a max push mul? Can we say like max push movement? And I guess we'll call this max pull movement. Okay. So this is now like pull. And this is change max pull movement. Change max pull. Max pull. And then we need pull and push movement as separate things. Okay, which means max push here. Push. And then we need to have both pull and push support here. Max pull movement and max push movement. Okay. And then our widgets that we're using to configure those things need to use the correct items. So we have max pull, change max pull, and then everywhere it says pull here, we just change push. Push and push. All right. So what I'm claiming here is that I want the maximum push movement to be just like actually higher. Okay, we want things to be like, we want parents to pull harder than normal references. And we want kind of the push fall off to be steeper, but the maximum push movement to be higher. And somehow this doesn't actually seem to change anything. I wonder if it's because we're not using max push movement. That's very likely that we just didn't actually change that part of the code. Yeah, we're still using pull here, like dumbasses. Okay. Okay, so let's try that. Okay, so what we've had pull at like 5, we had parent pull at like 10, then we had push fall off kind of also quite aggressive, but then we want to increase the push. Oh yeah. Oh yeah, we're getting somewhere. So now we can push things hard. Oh fuck, we have to be careful about okay, so this is like we just want all of these numbers to be kind of big because we kind of want things, we're kind of trying to say like we want things to aggressively happen. Like we want more bias towards when things are close together, I guess. Things are too close together now, which makes me want to kind of reduce this push fall off a little bit. We still keep the push amount the same, but we reduce this. Now, I don't like the fact that these guys are kind of getting like thrown out towards the edge. So how do we prevent that? Well, it's because they have like, you can see that like these guys that are thrown towards the edge don't have like a ton of connections pulling them inwards. I guess these guys do, whatever these are. So which kind of like indicates that we should reduce the push movement. So this is what happens if it's the same as pull. Things start just going towards the middle. It could be that also the amount of control we have over here is not really quite enough. So I'm kind of down, first of all, to like start these values at something that's a little closer to what we have been tuning towards. So I think we had like 10 on all of these for like really aggressive fall off. And then we want these like float sliders wherever the fuck they are. We kind of want like another level of precision here. Oh, wow. Hello. So TS just soding in the chat. Hello, hello, hello. Yeah, we don't have commands around here because we're shitty streamers. But what we are working on is we are working on trying to graph connections between our code base. So what we are showing in here is kind of like a shitty representation of the GUI framework we've been working on. So the thing that's showing these sliders here, right? What we've done is we've just kind of like used a language server to like walk all of the connections between elements. And we used tree sitter, which is probably not necessary. We could have used a language server, but we used tree sitter to like walk every file in the code base. And then we use language servers to find references between them. We built up a references list. And now we chuck them all onto the page and say like, things that are like each other, pull each other, things that don't like each other, push each other. And we're trying to see if we can gain any like, the goal is to eventually focus this on what we're working on today, right? So like we're going to integrate with Vim so that when we spend more time in certain areas of the code base, those things will be highlighted more in the graph. But before we do that, we have to have like a graph that doesn't suck at all, or like that doesn't completely suck. And so we're trying to figure out how the fuck do we lay stuff out without them like just totally fucking breaking. And we just kind of did the first thing we thought of, and we will see if we get somewhere sane ever. So I guess the ratio of push to pull is probably quite important, right? If we just increase both these numbers, we're just going to reduce stability of the simulation, would be my guess, right? Probably push and pull, the ratio of them is what's going to keep things constrained or fall apart. So how do we like keep things towards the middle? Like how are we like, why are these things getting pushed to the edge? I would guess because the push fall off isn't high enough, right? So if we just like fucking crank this push multiplier up, these things at the start coming in, but then also we need to increase the amount of movement that we're willing to do. But I think the higher this push multiplier number gets, the more like even most of these will be, right? Because we're going to basically say aggressively push stuff that's close together, and then eventually work your way, like aggressively push stuff that's close, but then fall off aggressively as well. I think that's what we want. Kind of just hand wavy. That's kind of how I'm feeling. This number feels too big. Okay, and then I guess we could also try like reducing some of, well, I need to look at Desmos again. So if we reduce C here on the pull side, lower number means basically more linear. More linear and also farther apart. So we say like really big number is like we want to pull things until they're really fucking close. Small number is like we want to pull things, you know, aggressively at the start and then like, sorry. if things are close by, like we don't really care, let them stay wherever the fuck they are. As they get farther away, the bigger this number is, the faster we start really yoinking them. Yes, that's what this number is. How fast we are going to like really fucking pull them. So for parent, we want that number to be relatively high because for parent pull, we want things to always be kind of close to where they're supposed to be in the file system hierarchy. So this number should be kind of high. And then I'm kind of okay with letting this number, like the references pull multiplier, kind of get a little smaller. And that should let stuff kind of spread out a little more. Okay. That's kind of reasonable to some extent. We need to make sure that like we might want to add some sort of like force that pushes stuff away from the edge. Some sort of like, you know, like bumpers for bowling. You want to say like, okay, we want things to be like centered as well. That's not crazy. But I kind of like, these are kind of some reasonable numbers for now. This is at least like something. We can like reduce the size of the nodes a little bit. So let's like kind of like keep this set of numbers just for a little bit, and let's see if we can like glean any information about like what we're actually fucking looking at here. Could be neat to increase and decrease the mouse wheel up down. Yeah, probably. Also, like probably some of these things need like different scales and other pieces, but yeah, I think that probably the clumping would look a little less bad if the radius of the points was smaller. So can we just like write down these numbers? Write down the numbers of, okay. We have max pull movement of 0.02. We have max push movement of 0.08. We have pull multiplier of approximately 5. We have parent pull multiplier of approximately 12 and a push multiplier of approximately 25. Already much better than it was earlier. Yeah, I mean, before it looked like absolute fucking shit. Need to serialize sliders now, sigh. Yeah, I mean, we could like, you could dump the current state into like a config file and then read the config file or something back, but you know, fuck it, you know. Yeah, what I want to know is probably, can we just start by rendering the name of what is hovered? That's probably the easiest thing to do. So let's just say, show what is hovered. Show what is hovered. Okay. So what do we do? How do we vet? I guess we already know which node is hovered. We literally just have to fucking write it down here, right? That's literally it. So can we just say, we have this like property list that we're working with, and can we just be like, we will copy from here, I guess. Copy pasting is the easiest way to write code. It's also the easiest way to write bugs, but who gives a fuck about that? So we'll have like name. Do we even need this thing to be like, does it even really have to be like a key value thing? It's easier to use it as a key value thing for now, but probably in the future, it would make sense for the name to take up the full width instead of saying name here. It's kind of fucking stupid, but whatever. Now this thing needs to get its name from somewhere, right? So what we construct our widget hierarchy like at the beginning, but the content of this label needs to change. But we support that. We support that. All we have to do is make we say selected name text retriever. It's a structure that has some sort of function get text, and it will return some text. I'm pretty sure. I'm pretty sure. And so this is going to take in self. We can't use its name because if you define a like a class inline like this, it doesn't get its like fancy little name. And what is this going to do? What is this going to do? We're going to say, we're going to have the node database, I guess. And we also are going to have like selected node. Node ID, question mark? And then to get the name, we just say like return self nodes. This is probably better as a pointer. Probably both of these things should be const pointers. And we say like self nodes get, nope. Oh, this is DB, my bad. Get node of self selected node, and then we return its name. Then we just need to say that when we like calculate our selected node, we assign this to something. So we say like selected node is a node ID because we didn't strong type here because like fuck it, I don't know. Sometimes we want it, sometimes we don't, sometimes we're lazy, maybe sometimes she's born with it. Shut the fuck up. And so that means that we need to like define the selected node thing. So we'll be like var selected node is a node ID is equal to 0, I guess, is probably an initial reasonable thing to write here. Okay, and then we can construct this name retriever as this. So we say selected name text retriever takes in a nodes of GraphDB. I don't know, nodes. Is this thing a pointer? I guess this is how this works. DB node, sure. Which means that this can actually be just, that's fine, we've already done it. We've already done it, which means that this is like this. And we're fucking violating strong typing constraints again, but fuck it. And then action gen, there's no action to perform. This is literally just a label. I think that we accidentally wrote key dnet twice here. That's really bad. It's a double free if I've ever seen one. And selected node comes from selected node. Okay, that might work. Yo, looking good. Seems like we added connections and some GUI elements today. Yeah, hell yeah. We're feeling pretty good about it for sure. What is this piss about? Does he want const here? I could read the error message, or we could just guess. Okay, so now we are definitely seeing the name show up here. And so I wonder if we can get like some form of like interesting. So everything here is in color picker. That makes sense. Dude, this is impossible to read. Can we add a like background to this shit? How do we add a background? We have like a stack widget that we can make is probably the play. So we go like widget factory make stack const stack is equal to this defer stack dnet or something as widget probably stack as widget probably. This thing is also maybe tryable because the allocations can fail in this language. Is this like a proper type now? Yes, which means that we can do like dnet this motherfucker later if we want. Here we say we make a property list. This property list immediately goes into the stack, but not before we put some sort of background into the stack. What is the background? Background must be some form of rectangle. And the fill style is just like literally fill whatever space you can. And the color is going to be, I don't know, R equals, I don't know, something like this? What the fuck did I just do? That's fine. Do I need to put this thing in a box so that it won't like fill the whole world? We'll find out. Then we're like, here's our rectangle. And we're like, shove this rectangle in the stack, please. And then the property list also goes into the stack like immediately. Stack push or widget dnet widget of the property list widget. Probably with some allocator. How about clicking on node toggles showing its name so that we can see many at once? And then probably we want to color those things as well. That's not crazy. That's definitely not crazy. Push widget or dnet. What? Oh, right. So the idea here is that I'm trying to use this instead of like a error defer as well. So it's like if this thing fails, like I'm just saying out loud in the function name, like don't worry about fucking freeing this shit if this fails. Because otherwise you have to go like you have to put this thing in a block, and you have to be like, okay, well, if this block fails and we error defer rect deinit like here, we're just saying like, fuck it, like we'll push a rectangle, and as soon as this function is called, whether or not we succeed, we fucking own that shit. And so that's why I just put like or deinit there, because sometimes I don't do that and sometimes I do. So like just saying or deinit makes it clear to me. I'm like, oh, this is one of those freeing functions. This is one of those crazy guys. Okay, and then just everywhere we're using property list before, in rendering, we just replace this with stack widget. Boom, boom, boom. Oops. Stack widget. Boom, 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 boom. And then I have a bunch of stack widget widgets. Fuck off, stack widget like this, with like this, like this. Stack widget. Why is it still like this? Stack widget size width. What are we doing, buddy? Oh my god. Stacked widget size here. Maybe reasonable? Let's see what that looks like. Fuck! 528. We need... Oh, here we say that this rect is fill. Fill that motherfucker up. 535, and this guy is probably like center or something, I don't care. Fuck. Stack widget as widget, of course. Why do I have all these as widgets all over the place? Okay. Background? We're close. Close enough. Close enough. Okay. So this is like scroll bar stuff in the scroll view. This all here is like cursor stuff in the layout. Then here, this is like the entire layout file. This node here. So like all of these guys are like within the layout file, and it kind of makes sense that the way we've structured things is that things that are within the layout file are farther away from the center of the world than the layout itself, because the layout contains references of all of its children automatically. So that's kind of interesting. What's like over here? Color picker stuff? Okay, so this is even vert layout. So this is kind of like a sidebar thing in the main GUI. Then we have color picker, color axis. Maybe this just isn't used. It seems likely. I don't really see a little line going to this. So can we like look at the color axis thing over there and see like what the fuck is going on there? Oh, this is used. But this is like the connection is maybe weak, or maybe like find references on this thing. Interesting. This definitely is used here, which makes it to here. Oh, but I think, oh, that's interesting. So the way that the reference hierarchy building works is we say here is like a list of rules for things that we care about that you should give names to in a tree sitter AST. Now, what I do not think that constant assignment is one of those things. So this like best axis function is in fact connected to color axis through this constant. But I bet you that best axis here, where the fuck is the names on this thing? Is this the wrong window? Do I just have this open twice? I bet you we can find best axis in here, and it's gonna be one of these blue nodes. Probably kind of far from everything else. Best axis. Best axis. Maybe we fucking can't find it. Oh, here. Best axis, I saw it. It's right here, this guy. This guy right here. This is the best axis function, who is connected to this color axis thing over here. However, because it goes through a constant, the system doesn't know that those two things are connected, which means that we might want to start adding like constants as some of the things that we track in the database. That's like kind of reasonable. Pop-up layer stuff. Who is... It might be nice to also show like who is connected to us. That's probably an interesting thing. Like when I hover here, we might want a list of the people who are connected. I also want to reduce the size of these. I'm in the wrong folder. I want to reduce the size of the items that we're looking at. They're too fucking big, dude. And it looks like I have the magic number 0.025 fucking everywhere. Point radius, we'll call it. And we'll kind of like maybe quarter it, half it. Yeah, 125 is fun for now. And can we go point radius like this? Boom, 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 boom. We are rendering these things like a million times, but whatever, it doesn't matter. Okay. I mean, now they're just like really hard to find. So I think that likely we are probably going. I suspect size change is probably where this is going to end up at some point. It seems likely to me that we're going to increase size of things that are kind of more relevant to us. I wonder if we can glean any interesting information about like what's in the middle, right? Because like I would have suspected that like widget. Yeah, this is too small. I want it to be bigger. I changed my mind. But maybe not as big as it was. Yeah, I want to know if there's anything interesting we can glean about like what's in the middle. Property list over here, scroll view here, text box over here. Like widget factory being in the middle is kind of interesting. Squircle renderer being in the middle is also pretty reasonable. Like pretty much every single widget in our entire code base uses a Squircle renderer. Like all of these guys, these are Squircles. So that kind of makes sense. Frame is kind of interesting. I wouldn't expect frame to be in the middle. Frame is kind of like our type for you have like a box of stuff and you want to put a border around it. We call that a frame. Probably adding some sort of border should make it easier to distinguish different things. Let's think about that for a second. We could do that. It's pretty straightforward. Let's try it. So here we'll just say like oh, we just use 0.5. Okay, so we'll do like outer R2 is this, and then we want like an inner R2. R is just not used here. That's kind of funny. And we'll do like 0.4 on this one. So we'll say between 0.4 and 0.5, we do one thing. So if we're greater than outer R2, we say get the fuck out of here. Else if we are, I guess we'll say like dist2 is this shit. If our dist2 is greater than the outer radius, get the fuck out of here. But otherwise, if our dist2 is greater than the inner R2, we render a different color. So here, we have like else for the last segment. Can we just do like black is black the color? I guess that will create some sort of border, but not in a way that's different than what exists right now, I don't think. So let's just do like red. Fuck it, I don't give a shit. That's kind of hype. I'm actually not gonna lie. That looks kind of sick. Clearly our push force needs to be higher, huh? I kind of want to like crank this up. So yeah, this is combo box being in the center here does not make sense. This is fucked up. That's kind of interesting. I wonder why that's happening. Because combo box definitely is only used in like a couple places. But just pull the colors from the Neovim theme. Yeah, that's not really crazy, I guess. So it's definitely like working a little bit, right? We can definitely see that like the color picker initialization here is close to the widget factory, which makes sense. Oh, I wonder if just like the top level thing of every function or of every widget is close by because the widget factory owns them all. So maybe like construction of like button.zig, even though that's not used in a ton of places, it's used by the widget factory, which is central right now. Maybe that makes sense. And then here's like button stuff all around here. This is property list stuff. And then like, where's like the parent property list? Yeah, property list, make property list ends up all the way over here. So probably like kind of like within like this radius here, we're going to see like constructors of all of our different widgets. Yeah, here's like combo box construction. Oh, and I bet you more the widgets that have more configuration will be closer to the center because those configurations are all stored within the widget factory because the widget factory owns the configuration of like everything. Okay, so maybe that's not crazy. Maybe that's not crazy. Yeah, right, like here we're saying like even vert layout shared, which is like the shared state of the vert layout thing. We're seeing like Squircle renderer, we're seeing widget vtable over here. Okay, yeah, like combo box in it. Okay, maybe that is like somewhat sane. Maybe that's somewhat sane. Now I think probably the next step here is probably to weight things based off of some like heuristic of importance, right? Because like surely we don't actually care about everything. I think what we want to do is we want to like focus in on like one node and maybe make that node bigger. And as we get farther from that node, like his parent will stay kind of big, his references will stay kind of big, things that reference him will stay kind of big. But as we get like more and more layers away from him, maybe like the size and also like the weight of these things, since like these things are like pulling each other, we can pretend that like weight contributes to like how much they're willing to push things around. I think that maybe we like decrease that as things get farther away from the thing that we care about most. But I believe that is a problem for tomorrow. This is way, way, way better than we were like at the beginning of the stream. We have like some form of stability here. And like we have some form of structure here. Both of those things are very exciting. And we have like some tunables here that we can like play with to see if we can like improve it in the future. But for now, I'd say this is a major improvement. So we will call it there for today. Tomorrow we will come back and work on this more. I have to think about what the plan of action is for tomorrow, but hopefully I'll find something. If you want to see that, swing back by tomorrow. We stream most days, 12:30 Pacific time to 4 o'clock Pacific time. It is 4 o'clock Pacific time now. So if you are watching us live, 3.5 hours ago to now is when you should expect to see us. If you want to keep up on the project, but you're like, I can't fucking watch you stream every day for 2 hours. That's like, or 4 hours. That's too much shit. There is a YouTube link in the Twitch description where the main segment streams go up. The main segment streams is what you're watching right now, but there's also kind of this thing we call happy hour, which is like kind of like behind the scenes work, things that are like not worth titling and thumbnailing, but are worth doing. So today in happy hour, we're working on we were working on like pulling in the GUI framework that we've been working on to this project so that we knew that we would be like working on that. So we were working on like dependency hell, dependency mapping, exposing the GUI framework as a dependency, stuff like that. If you want to see that stuff, you have to hit the join button on YouTube, Patreon, or subscribe on Twitch, and you will find VODs of that part in the appropriate place. Code for this will eventually end up on GitHub, link in the Twitch description, under the code map repo. We have mega cleanup to do, but now that we have something that kind of works, I can work on cleaning it up without worrying about actually accidentally fixing bugs, which is pretty sick, which means code can go up somewhat soon. Otherwise, I think that's all the plugging we got to do. YouTube, peace out. Twitch, let's find someone to raid.